All right, let's dive into something you do, I don't know, 100 times a day without even thinking about it. What actually happens when you click on a link. We are going to follow that one little click on its absolutely incredible journey across the entire globe.
It just feels like magic, doesn't it? You type in a website, you hit enter, and poof, it just appears. But behind that super simple action is this lightning-fast, totally complex sequence of events that spans the entire planet. So let's pull back the curtain and break down that secret journey, step by step.
So the very first thing that has to happen is a translation. Here's the deal. Computers don't understand names like Google.com. No, they speak in numbers, specifically IP addresses. So before a click can even think about going anywhere, it has to look up the right number in what's basically the internet's giant phone book.
Okay, so here's a quick roadmap of the entire trip. First, our request has to find the server's address, right? Then it gets all packaged up into these tiny digital parcels. After that, a global postal service figures out the best route for those parcels, and finally, the website's data comes all the way back to you. It all starts with step 1, finding that address. In that phone book, it's called the Domain Name System, or DNS for short. The second you type in a URL, your computer kicks off this super fast search. It checks its own memory, then it asks your operating system, then your router, then it asks your internet service provider. All of this happens in a fraction of a second, just to find that one unique IP address for the server you're trying to reach.
Okay, so we have the address, awesome. But you can't just yell your request out into the internet. Nope. It has to be properly formatted and packaged up for its long journey, and it has to follow the super strict rules of the internet.
And those rules have a name, TCP/IP. You can think of it as the official language and like the postal regulations for all internet traffic. The first part, TCP, that's the transmission control protocol, is what chops your request into these neat little pieces. And later, it makes sure they all arrive safely and get put back together in the right order. It's basically the quality control for our digital mail.
So what are these little pieces called? They're called packets. And seriously, everything you do online, from watching this explainer to sending an email to streaming a movie, it's all chopped up into these tiny, manageable chunks. A single photo you post could be broken into thousands of these individual packets just to get it across the network.
But these packets, they're not just random bits of data flying around. Oh no. Each one is a perfectly built little container, and it's carefully designed with a specific anatomy to make absolutely sure it doesn't get lost on its way.
Every single packet has 3 key parts. First, you've got the header. That's the shipping label. It's got the from address and the to address. Then you have the payload. That's the good stuff, the actual data being sent. And finally, there's a footer, which is like a little signal that says, hey, this is the end of the packet, we're all done here.
All right, our packets are addressed, they're sealed, and they're ready to go. Now they're about to be sent through the internet's just mind-bogglingly complex postal service.
You see, the internet isn't just one single thing. It's really a network of networks. And each one of these individual networks is called an autonomous system, or an AS. Just think of them as these huge regional postal districts, run by ISPs, big tech companies, or universities. Your packet has to hop between a bunch of these just to get where it's going.
So how many of these postal districts are we talking about? Tens of thousands. About 64,000 of them. It's this decentralized web of all these independent networks that somehow have to talk to each other perfectly. So, how in the world do they decide which way to send all those billions of packets?
Well, that is the job of something called the Border Gateway Protocol, or BGP. It is the master traffic controller of the entire internet. At the border of each network, BGP looks at a map of the internet and decides the best path to send a packet. And get this, best doesn't always mean the shortest or fastest path. It's also looking at things like network traffic, cost, and even private business deals between the networks. So your data might actually take a slightly longer route just because it's cheaper for your ISP. Kind of wild, right? So we've talked a lot about the how, the protocols and the systems. But who actually runs these massive networks? Who are the gatekeepers that connect your house to this global system?
Well, they are, of course, the Internet Service Providers, or ISPs. These are the companies we pay every month to plug us into their autonomous system, which in turn connects us to all the other ones. They're basically our on-ramp to the global digital highway. And just to make this a little more real, here's a look at the major ISPs over in India. You can see how just a handful of very large companies control internet access for millions and millions of people. This whole competitive business landscape is really what holds the entire system together. So our little data packet has crossed oceans, continents, hopping between these giant networks. It has now arrived at your local ISP. But it still has one final and super important journey to make, getting from the ISP's network into your home and onto your screen.
This final leg of the journey is called the last mile. And it's probably the most overlooked part, but it is so crucial. I mean, the speed of the entire global internet doesn't matter one bit if this last connection, the one cable coming into your house, is slow. It is often the single biggest bottleneck in the whole system.
And this is a pretty good breakdown of the two main types of connections for that last mile. Most of us at home, we have a contended connection. That means we're sharing bandwidth with our neighbors, which, by the way, is exactly why your internet might slow down at 8 p.m. when everyone's streaming movies. Businesses, on the other hand, often pay a lot more for a dedicated connection, which guarantees their speed on a private line that's all their own. And here it is, the final piece of magic. Your ISP only gives you one public IP address. So how is it possible that your laptop, your phone, your smart TV, and your tablet can all be online at the very same time? Well, that is thanks to something called Network Address Translation, or NAT. Your router basically acts like a receptionist. It takes that one public address and gives out private internal addresses to all your devices, managing all the traffic so everything just works. So there you have it, the incredible journey of a single click. It gets translated, packaged, routed across a global web of private networks, and delivered to your screen in the blink of an eye. It really feels like a public utility, doesn't it? Like water or electricity? But the truth is, it's a patchwork of competing companies. And that leaves us with a really big question. Who is responsible for making sure this incredible system stays open, fair, and accessible for everyone?